All right. Well, first I want to just point out Michelle is great because she's been the one that did all the hard work to get everyone here. And also Ralph and Paul have contributed. And Dave Schimmel, who is late. Typical Dave. And yeah, so we're here today to talk about observing terrestrial ecosystems and the carbon cycle from space. My subtitle is From Stovepipes to Synthesis, which will come in at the very end of this brief talk to give some context for why we're all here. Just to go over what we're going to hear about today, we're going to hear about the carbon cycle, terrestrial ecology and modeling of that. Then we're going to have a nice lunch. And then we're going to hear about 4 different remote sensing technologies and missions associated with them, except for the last one, because there isn't, well, there is Hesperi in the far future, but these are missions that are planned in the next couple of years. So it's vegetation structure and biomass, JEDI, ecohydrology and ecostress, atmospheric CO2 concentration and chlorophyll fluorescence, so CO3, and imaging spectroscopy. So just to go back a couple of decades, this is ERT, which later became known as Landsat 1, launched in 1972. A couple years after that, there was a symposium, the 3rd symposium on ERT, and there was had this equation, which some of you, well, cut off there, NDVI, which is a measure of vegetation greenness, and that's when it comes to understanding the carbon cycle from space, and really the carbon cycle, and not just the broader Earth system, that's what we had for a couple of decades, is basically measures of greenness, whether it was Landsat, MODIS, AVHRR. And now we have a great decades-long record of that greenness. But we're sort of hitting the limits of that. And again, this is cut off. Anyway, the title there says Droughts are endangering the Amazon. So we have the Amazon. It experiences droughts from time to time. There was a big one in 2005, 2010. We're probably headed into another one this year with the El Nino. There's a lot of carbon there, 86 petagrams of carbon, quarter of all Earth species, and over parts of it, we see massive diebacks during these drought events. And we've sort of hit the limits of the technologies that we have in orbit today. So you have, a list of papers in prestigious journals, saying that the Amazon greens up during dry periods, and then other ones that say, oh no, it does not, right? And this is a nice quote that I like from Greg Asner. And it says, "It's nobody's fault. These guys are trying to squeeze blood from a stone. These uncertainties are exposing the limits of space-based sensors that were designed 20 plus years ago. These issues are not going to be resolved by the technology that is in orbit today." And then you might think, well, okay, if it's not going to be solved by what's in orbit today, what about on the ground? What about going out there and measuring it? Well, I have 3 plots. They're all from left to right, going from south to north, zonal plots. And then on the y-axis here, we have our best estimates of evapotranspiration and productivity of plants, and then a plot of eddy flux tower FluxNet sites. And you can see that in the regions where we have the most vegetation activity, we have only a handful of sites. And this pattern repeats itself over and over again. So here is a similar plot, again, going from south to north. You have the equator here. Our best estimates of vegetation carbon and total carbon, also including the soil stocks. And then estimate, or the number of, or the density of forest plots. And we have this huge peak here in the mid-latitudes where there's lots of rich countries and lots of universities, the U.S. Forest Service, contributing to that peak. These are peaks from Europe, and almost nothing there in the tropics because it's difficult to get access there, for instance, in the Amazon. And here's another plot, again, going left to right, south to north. And this is a histogram of the total number of vascular plant species observed in these zonal bins. And then this in the black, okay? And then here we have the number of those species where we have trait data. So that's data about aspects of the plant, for instance, nutrient concentrations in the leaves, or the maximum rate of carboxylation. And we see this peak in the tropics, but very sparse data relative to the total number of species. So if we want to get that broad global coverage, space is the place to do it. And I don't want to make it sound like there's nothing new in orbit. In the last decade or so, there's been a couple of new technologies that have gone up. So we have GOSAT and OCO2 measuring greenhouse gas concentrations as well as fluorescence. There's been the ICESat, which is a LiDAR, which has also looked at vegetation structure. And then we've had some microwave instruments like AMSR, SMOS, SMAP, looking at things like soil water and canopy water. But then why are we all here in this room, or at least some of us that are going to go on to the workshop later, is that we have this wonderful opportunity that presented itself last year when we were proposing this workshop. This is the International Space Station. And then here, this part here is the Japanese experiment module. And then this part is the Japanese experiment module exposed facility. And you see these little boxes that stick out here. That's where there's a little robot arm that can take an instrument out of, for instance, a SpaceX Dragon capsule and plug that instrument in and then have it point down at Earth. And so recently we've had selected the JEDI LiDAR mission, which you're going to hear about later today. It's going to be studying ecosystem structure and biomass. The EcoStress mission, which is a thermal radiometer, which is going to be looking at ecohydrology and evapotranspiration. And then the OCO3 mission, which is a follow-on to OCO2, but will be on station and have a pointing capability. And at the time that we proposed this, there was the potential that there might have been an imaging spectrometer along with these. It's less likely now, but there are possibilities that it could be in space around the same time, which would be looking at these plant traits, things like nutrient concentrations in the leaves. So together, these instruments, and especially if they're flying at the same time, will be a real revolutionary leap in looking at more than just greenness, and we'll really be able to have simultaneously measurements of ecosystem composition, function, and structure. And some of you might be familiar with the A-Train. It's a series of satellites that follow each other about 30 seconds apart in space. The OCO2 is part of the A-Train. But for the most part, it's been atmospheric instruments, looking at things like cloud droplet size and stuff like that. And what these instruments could be is something like the C-Train, the carbon train. So, but we have these 4 instruments: OCO3, EcoStress, JEDI, and I have this dashed line for the imaging spectrometer because it's not actually a mission. And they've all been proposed and selected based on their own merits. They all have great science questions that proven themselves. And so they're a bit like a stovepipe. That comes from NASA system engineering and principles that you reduce your contingencies. You don't want things to be dependent on one another in order to meet your requirements. Well, they've already met their requirements. So now we can go from something like that in the course of this workshop to something like this. Again, I got cut off. Where we look at where are the intersections and what good science and new science and even better science can we get out of these intersections. And then why the timing of this workshop, beyond the fact that these, sorry about that. So 3 of those potential questions would be, taking things from each of the instruments, for instance, taking the productivity or the flux from OCO3, water flux from ecostress, and looking at water use efficiency. Same thing for OCO3 and spectrometer, looking at light use efficiency. And we can look at the turnover time of carbon, or residence time of carbon, with JEDI and OCO3, and then come up with a really basic understanding of change in the carbon storage and the terrestrial ecosystems. And we have water use efficiency plus light use efficiency times tau in a sort of abstract way, representing that. And then we have, beyond this short-term opportunity, right now there's what's called the decadal survey process going on. Panels are being selected. This is a document which the federal government, NASA, USGS, NOAA, go to the National Academy of Science and they ask, what should our priorities be for the next 10 years? And this is the one that came out in 2007, which laid out, the priorities for the last 10 years. We're now in the process, or the National Academy of Sciences is in the process of creating one for the next 10 years. We're somewhere around here in the process. And so by coming together at this workshop, we can write a document which hopefully inform that process about the value of synergies across multiple instruments, so that not only do we get the instruments in space that we want in the next 10 years, but we get them flying simultaneously, or if that's necessary, in order to answer the science questions that we want. And with that, I'll open it up to questions.